Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. The Management Plane Explained introduces the third and often most visible component of software-defined networking architecture. The management plane is the interface layer that allows network administrators and automation systems to interact with the network. It serves as the control point for pushing configuration changes, monitoring performance, and orchestrating policy deployment. Unlike the control and data planes which operate behind the scenes, the management plane provides direct visibility and interaction with the SDN controller and the overall network state. This plane is directly covered in the Network Plus certification under Emerging Technologies Objectives. Candidates are expected to recognize how the management plane differs from other planes and how it enables centralized oversight through tools like graphical user interfaces, command line access, and application programming interfaces. The exam frequently includes conceptual questions that explore how administrators use the management plane to define behavior, automate provisioning, and monitor operations across virtual and physical environments. The management plane is the part of the software-defined networking model that allows for configuring, monitoring, and managing the network through software. It interfaces directly with the SDN controller, making it the administrative access point to influence how the network behaves. While the data plane handles packet forwarding and the control plane determines paths, the management plane is where humans and automation tools shape policies, issue commands, and collect feedback about network status. This separation of duties creates a clean operational model with well-defined responsibilities at each layer. The management plane performs several critical functions that support both day-to-day operations and strategic changes. First, it provides the mechanism for creating and deploying policies, such as quality of service rules or security access controls. Second, it supplies real-time status reporting and network visualization tools that help administrators understand traffic flow, bottlenecks, and device health. Third, it collects logs and generates alerts, allowing teams to respond quickly to anomalies or failures. These capabilities turn the management plane into a central nervous system for modern networks. Administrators access the management plane using a variety of interfaces. Graphical interfaces provide dashboards, charts, and widgets for visualizing status and performance. Command line interfaces offer precise control and scripting capabilities for advanced users. Application programming interfaces, or AP, allow integration with automation tools and business platforms. These interfaces may be vendor-specific or based on open standards, but all serve the purpose of interacting with the SDN controller through the management plane. Understanding these tools is essential for efficient and scalable network administration. Interaction with the SDN controller occurs through a defined set of operations. The management plane sends instructions to the controller, which then processes those instructions into flow rules and passes them to the network devices. At the same time, the controller collects state data from the devices and feeds it back to the management plane, where it is visualized or logged. This bidirectional communication allows administrators to make informed decisions based on accurate, real-time data and to adjust network behavior dynamically as conditions change. One of the most important tools within the management plane is the use of RESTful Application Programming Interfaces, or REST APIs. These interfaces allow software applications to communicate with the SDN controller using standard web protocols. REST APIs are platform-agnostic and scriptable, meaning they can be used in Python scripts, Ansible playbooks, or other automation tools. Through these APIs, administrators can automate network provisioning, implement changes across hundreds of devices, and respond to events without manual intervention. REST APIs form the backbone of network programmability in modern architectures. Security is a critical consideration in the design of the management plane, because this layer provides administrative control over the entire network. It must be protected against unauthorized access. Role-based access control ensures that only approved users can make specific changes or view sensitive data. Many systems integrate the management plane with enterprise identity solutions like Active Directory or multi-factor authentication providers. Logging every access and configuration change is also essential for auditing and compliance, making the management plane not only powerful but also accountable. Real-time monitoring is one of the most valuable capabilities of the management plane. Administrators can view current traffic statistics, link statuses, device health, and policy enforcement metrics from a single interface. Many systems allow for the configuration of alert thresholds, where certain conditions like high latency or failed connections trigger warnings. Dashboards consolidate this information into a visual format that makes it easier to interpret and act upon. These insights support quicker decision-making and help prevent small issues from becoming larger outages. The management plane is also where automation and orchestration tools are integrated. These tools allow administrators to define workflows that apply configurations across multiple systems at once. For example, a change in network policy can be written once and pushed to every switch and router in the environment using a script or orchestration template. These capabilities reduce the need for manual entry, lower the risk of human error, and allow networks to respond faster to business needs. Integration with cloud platforms and software tools enables consistent policies across hybrid environments. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Securing the management plane is essential to maintaining control and integrity within a software-defined networking environment. Because this layer governs all administrative functions, it must be protected from unauthorized access and tampering. Management traffic should always be encrypted using protocols like HTTPS or SSH to prevent interception. Access to management interfaces should be limited to trusted hosts and networks, often through firewalls or access control lists. Multi-factor authentication adds another layer of defense, requiring users to validate their identity through multiple methods before making changes. Examples of management plane tools help illustrate how this layer operates in real-world environments. Cisco DNA Center provides a centralized dashboard for network control, offering visualization, automation, and policy management through a unified interface. OpenDaylight, an open-source controller platform, offers dashboards and API support for broad customization. Tools like Ansible or custom Python scripts can also connect to REST API to configure devices or enforce policies programmatically. These tools make the management plane not only accessible but also extensible, allowing for integration into broader IT workflows. Logging and auditing are core responsibilities of the management plane, ensuring that every change is recorded and traceable. Logs can show who made each change, when it occurred, and what parameters were affected. This historical data is essential for meeting compliance requirements and investigating incidents. Some platforms also allow configuration rollback, where an administrator can undo recent changes and restore a known good state. This capability adds a safety net, encouraging more frequent updates while reducing the risk of persistent errors. Integrating the management plane with business applications creates a more responsive and intelligent network. Through APIs, the network can adapt dynamically to application demands or user activity. For example, a monitoring tool might detect a spike in traffic and trigger a configuration change to allocate more bandwidth. A business application could request prioritized traffic for critical transactions during peak hours. These event-driven responses make the network behave more like a flexible resource than a static infrastructure, aligning performance with real-time needs. Troubleshooting from the management plane provides deep visibility and context. Administrators can trace issues back to specific changes, users, or time windows, helping isolate problems faster. Logs, alerts, and real-time data allow teams to correlate symptoms with root causes. By comparing the actual network state with the intended configuration, discrepancies can be identified and resolved quickly. This centralized view reduces the need to access individual devices and streamlines the entire diagnostic process, which is an important efficiency gain in complex environments. The management plane also plays a key role in hybrid environments that include both on-premises and cloud-based infrastructure. From a single interface, administrators can manage switches, routers, virtual machines, and cloud gateways. This unified control simplifies the enforcement of consistent policies across different platforms and locations. The management plane becomes the link between legacy infrastructure and modern virtual networks, helping organizations transition smoothly to cloud-first or hybrid models while retaining centralized oversight. When comparing software-defined networking management to traditional methods, the difference is clear. Traditional networks rely on manual configuration of each device, often requiring time-consuming login sessions and device-specific knowledge. In contrast, SDN provides global, policy-based management from a single point of control. Changes can be applied across the network instantly, and new devices can inherit existing policies automatically. This centralized model significantly improves scalability, reduces errors, and shortens response times to operational needs. For the Network Plus exam, it's important to understand the distinct role of the management plane. Questions may ask how it differs from the control and data planes, how APs are used to enforce policy, or what tools are commonly used for centralized control. You may also need to identify benefits such as faster troubleshooting, unified visibility, or support for automation. Mastering the function and value of the management plane is essential for grasping how modern networks are designed and operated. The management plane serves as the hub for all configuration, automation, and monitoring activities in a software-defined networking environment. It interfaces with users through graphical tools, command line access, and programmable APIs. With real-time visibility, centralized control, and automation capabilities, the management plane plays a crucial role in maintaining agility, performance, and security. As networks become more dynamic and software-driven, understanding how this plane operates is fundamental to both the exam and future networking success. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.